All right, so part 2 is starting today of the EOC review. We're doing numbers 11 through 21, and it starts with the sequencing, okay? And what it means is I'm looking specifically at the order in which the angles are listed in the triangles, okay? And if they are similar, okay, basically it's DEF is the image. All right, what does that mean? It means that the triangle has not changed shape or size. That's the only thing that is important about stating that it is a translation, okay, is that the image has not changed shape or size, okay? The 3 units down part, that's like a distraction, okay? That part doesn't matter. So which angles then are corresponding? It would mean that the first angle in the sequence on both triangles are similar, A and D. A and D. All right, which would also mean that the second angles are congruent, B and E, and the third, C and F. Okay, so basically all I'm doing is just reading the sequence and I can tell. All right, now let's talk about the sides. The sides that are corresponding obviously is a combination of 2 angles put together. So I just start with the first 2 angles in the sequence, AB. So what do you think would be corresponding to AB, Elizabeth? On the other one. The first 2 on the other one. DE, very good. DE. And then what about to BC? All right, Maya? EF. And Trey, what about for AC? What would correspond? Okay, we'll look up here. Look at the sequence. A and C, first and third. So what would correspond on the other one? Can anybody help him out? All right, just tell me. DF. Okay? All right, try to stay up with us. Okay, so really, guys, that's why the whole question is about sequencing, because that's really how I tell what's going to be congruent and corresponding. All right, on 12 and 13, here's the concept I need you to understand, okay? Your answer will not be asked to explain, okay? Your answers are yes, but here is why. With any type of transformation when it comes to a reflection, a rotation, or a translation, I am not changing as long as both lines go through the same transformation, then it's not going to change the fact that they're parallel. Okay, so the image absolutely will be parallel as well. Now, if it had said 2 lines are parallel and then line A is reflected but not line B, well then obviously the image the lines are not parallel anymore. But if both lines undergo the same transformation, they absolutely are still parallel, okay? And so that's why my answer is yes. That's really all you need to know about those parallel lines. And it is a question on your EOC, okay? So you'll want to star it. All right, let's talk number 14. Okay, number 14 says a triangle has interior angle measures of 45 and 62. Find the third. You need an equation. Which means if you need an equation, that means you need a total. Does anybody remember what the sum of the angle measures of a triangle add up to? 180. Okay, so that's going to be a part of this. Set up your equation and solve for x. All right, guys, so 45 plus 62 plus x equals 180. 45 plus 62 is 107. And when I subtract that from 180, 73. Who got 73? Anybody else get 73? Now, on 15, guys, you're going to solve for x the exact same way. But wait a second, you only know one of the angle measures. Right? Do you only know one? I only see 54. How am I going to know what this one is?
There's always 90 degrees.
Yeah, there's a box there. That box means it's a 90-degree angle. All right, so factor that into your equation, find x, and then use that information to find y. All right, so 54 plus 90 plus x equals 180, 144 plus x, subtract it, and x equals 36 degrees. Who got 36 degrees? Sarah, Logan, good. Eric, 36. All right, so now I actually have all the information I need to find y. Can anybody explain to me how they found y? Ethan? Yes, it is. So my rule says that my exterior angle is congruent to the sum of my two interior angles. Two interior angles. So 54 plus 90, I actually already did that. It's 144. It's up there in my equation. Okay, so you don't have to show any work. You can just say y equals 144. If you recognize that, then your work in your equation actually solved that as well. The other thing you could do is recognize that this is on a straight line here. So you subtract 36 from 180 because that's the measure of a straight line, and you would still get 144. All right, so that's through number 15. Now let's talk about number 16. Okay, so because number 16 is not a triangle, my sum cannot be 180. So how am I gonna figure out what my sum is? How in the world? What if it was a 6-sided figure? What if it was a 10-sided figure? I need a sum to write my equation. I need a total. Is there a formula perhaps that I could use? Elizabeth? You're close, but I need to actually use my formula, n minus 2. So take the number of sides and subtract 2, and then multiply that by 180. And now you can use that formula literally to find any total, any sum of any number of sides, okay? So how many sides are in number 16? How many sides? 4. So what's 4 minus 2? 2. What's 2 times 180? 360. So that's how I know that my sum is 360. And then, what goes on the other side of my equation? X plus 92 plus 78 plus 72. And they all equal 360. All right? So go ahead and solve for x. All 4 sides together add together to be 360. So what does x have to be? Okay, x plus 92 plus 72 plus 78. Combine what you know. Subtract. And x equals 118. 118. Who got 118? Awesome. Good job. All right, does everybody understand how to find the sum? Because that number, the 360, it might not be the sum on your end of course exam. You might have a 6-sided figure. Are you going to know how to find the sum? Use your formula, okay? All right, so let's go down to number 17. Are the triangles similar? Well, let me remind you, in order for triangles to be similar, all of the angles must be the same measurement. By the looks of my sequence here, can I tell just by looking at these measurements? Can I tell? No, I can see that 82 is the same, but I need to know what x equals. If it's even off by 1 degree, they are not similar. Okay, so I need to solve for x in one of the triangles so I can compare my measurements. Go ahead and do that if you haven't already. All right, is anybody still working on number 17? Okay, let's go over 17. I did 82 plus 25 to get 107. And then when I subtracted, I got 73 and I subtracted, wait a second, not 25, 73. Okay, when I subtracted, I got 73 degrees. Okay, so look here. Look up here, guys. No matter what you're doing, I want you to watch up here. So if x is 73, right here, it goes 82, 73, 25. So guess what it's going to be on the second triangle? 82, 73, 25. So, because of that, yes, they are similar because all three angles are the same measurement. You see how I proved that? If two of them are 82 and 73, the last one has to be 25 in order to equal 180. All right, number 18, a man on stilts. 9-foot tall man. So he's not actually 9 feet tall. He's standing on stilts. What do you need to solve this? It starts with a P.
Pythagorean.
No, not Pythagorean theorem. It starts with a P. It's a proportion. You need a proportion. A 9-foot tall man stands on stilts, casts a 15-foot shadow. A similar oak tree is 25 feet tall. How long is the shadow? You must show, I told you right there, you got to show a proportion for credit. Okay, so go ahead and do that. Go ahead and do that if you haven't already. And if you have, keep working until I say stop. And then we'll go over it again.
So right there.
Guys, so my proportion, 9 over 15 equals 25 over x, cross products, divide and round your answer, 41.7. If you said 42, that's fine. If you said 41.6, that's fine. All those are fine. All right. Does anybody remember that first method that I learned? It has an X column and a Y column, and there was a standard set of values that I used, -2, 0, and 2. Sherelle? No, it's called using a table. You guys remember using the table, and I had X values that I plugged in? So that's one of the methods. It is not the method that I would encourage you to use, even on your EOC. You're not going to be asked to use that method, but it is one that we learned. The other method is the one that I'm going to encourage you to use, and that is the y equals mx plus b. Using the slope, well, that's part of it. Using the slope and the y-intercept, okay? Because remember, that last number, and if you remember this, you're going to answer in the next question right. The y-intercept, the last number in the equation, is the first point on my graph. And then I follow my slope for my second point, all right? I'll explain it more in a minute, but that's the slope and y-intercept to graph. Look at number 20. I'm going to ask you a question that I asked you, oh goodness, 50 times probably over the course of a month. It seemed like it was like this never-ending theme for chapter 4. Is the equation ready to graph? What I was actually asking you is, was the equation or is the equation in slope-intercept form? Is it? No, it is not. Because I need, and we just went over it, y equals mx plus b. So get this equation, -3x plus 4y equals 36. Get this equation in slope-intercept form. And at that point, it'll be ready to graph. Okay? -3x plus 4y equals 36. Let's see, Mason, what is the first thing I need to do to get this equation in slope-intercept? What's the first thing I do? Yes, add 3x. Okay, made me a little nervous there for a sec. All right, now, Elizabeth, what is the first term I write after the equal sign?
Your 3x.
Yes, 3x, because it's mx plus b, and then plus 36, but I'm not done yet. Anthony, what do I need to do now? What's my last step to get this in slope-intercept? Yes, everything. Don't skip any terms. You must divide all of them by 4. Now, let me ask you this. Do I need to leave, hold on. Do I need to leave my fraction as a fraction, or can I change it to a decimal?
You can, but it's better as that so you can graph it.
Okay, so yes and no. Okay, technically 3/4 is the same thing as 0.75. However, you lose your rise over your run, so you can't graph it. If I were to graph this equation, Logan, where would my first point go in my graph? If I was going to graph this equation, where? Yes, very good. It would go on the last number. What does the 9 stand for again? Y-intercept. So I would plot it on the 9, but more specifically on which axis? The y-axis. So I go up to a 9 and I plot my point. And Ethan, where do I go from there? I went up to a 9, I plot my point. According to my equation, where do I go from there?
Up 3 more.
Yes, very good. Up 3 more, so up to a 12, over 4, plot my second point. All right, and that's how I would graph a linear equation. You're about to do that on number 23. Okay? All right, let's talk about number 21. You collect data about the number of absences in a school year. That variable, guys, what does it say? Absences in a school year, what? X. It's going to be helpful for you if on your exam, if you write off to the side, X equals absences. You're naming the category now. It's no longer, oh, well, X. No, it's absences. Absences are your X value. What does X stand for here, guys? Absences, okay? Have I proven my point? Okay, now let's keep going. And the final exam scores, oh, Y. So you need to write Y equals exam score or score. Y stands for your score. For several students, an equation for the line of fit is Y equals negative 4x plus 95. Interpret the slope and Y-intercept. All right, so we're going to start with the Y-intercept. I want you to picture, and I'm going to erase it in just a second, but I need to kind of give you a visual on this. Okay, so we just talked about on a graph, right? What is the Y-intercept for this equation?
95.
It's 95. So if this were like a really gigantic graph, I would go up to a point up here and I would say this is 95, right? And I would plot my point on 95. Are you sort of with me? How many did I go on X? Did I go either way on X at all? No, I went 0. So what you need to understand about the Y-intercept is that your X value here, what does X stand for? What does X stand for? Absences. Your X value on the Y-intercept is always 0. 100% of the time. Every single time. So now let's revisit the interpretation. So when X is 0, and what was X? Absences. So when there are 0 absences, you would expect a score of 95, whatever that Y-intercept value is. All right, so what is it saying here? It's basically saying absences directly affect your grade. Would you agree? Have you kind of experienced that too, maybe? Like you miss school and your grade goes down, you miss a test, you have to make it up and you don't do as well on the test? That happens, all right? It's not natural for you to miss 20 days of school in a school year and your grades go up, okay? Usually that doesn't happen. So now let's talk about the slope. Well, you have to be able to look at the equation and tell me what the slope is. If you can't do that, there's no way you can interpret it. What is the slope in this equation? It is negative 4. And we could write it negative 4 over what? 1. What does negative 4 stand for? The rise or the run? The rise. Okay, so it's rise over run. Everybody with me? Rise over run. Rise is which value? X or Y?
X.
No, rise. So rise, look, rise is your Y value. Okay, what did we say stood for Y? Scores. The scores. What did we say stood for X? Absences. So here's what it's saying. Your score will decrease how many points? 4 points for every 1 absence. Okay? So you're naming the category. You understand that rise is your Y value. Here, Y stood for score. Your run is your X value. Here, X stands for absence. So we are predicting, based on the slope, that the score will drop. Okay, ignore the screen for a second. I'll turn it back on. The score will drop. $4 points. for each absence. Okay, does that make a little more sense now? You don't need to be to 100% yet on this. I'm going to give you another problem to work later in the week that revisits this interpretation. But what you need to remember on the Y-intercept, whatever the X category is, it will always be 0. And then that number at the end of the equation, that's your value. Okay? And then we can interpret the slope based on rise over run. And that's where we're going to stop for today. Okay, and then we'll pick up more tomorrow.